Hello everyone. Today we will study about the power in the series and uh, parallel circuits, and we will have some, kind of interesting lecture today, and I hope that you people will enjoy and learn something from this lecture. So just tune and never go everywhere or kind of never go from this lecture. Just attend full of them and you will get some interesting points or ideas regarding parallel and series circuit and the power across each resistor. So stay tuned. बिस्मिल्लाहिर्रहमानिर्रहीम। अच्छा, आज हम पढ़ेंगे पावर पावर के बारे में पढ़ेंगे कि जो हमने प्रीवियसली पैरेलल सीरीज सर्किट पढ़ा था उसमें पावर की क्या पोजीशन है, वो भी आया डिवाइड या सेम रहती है अक्रॉस इन रेजिस्टेंसेस। सो फॉर एग्ज़ाम्पल हम पहले जो है ना वो सीरीज सर्किट उसके लिए लेते हैं R1, R2 and R3 which is connected to 100 volt, that is R1, R2 and R3. And just for example we got 10 ohm, 20 ohm and then 30 ohm. Okay, start. Is that okay? So first of all we will have an current. हम करंट को पहले मालूम करेंगे I, उसके बाद जो है ना हम अब पावर थ्रू ईच रजिस्टर हम जो है ना मालूम करेंगे, क्योंकि पावर का फार्मूला हमारे पास जो आ रहा है वो है, अच्छा, फॉर द इंस्टेंट वी गॉट फॉर एग्जांपल पावर इज इक्वल टू VI. So this is one part of power. इसका जो यूनिट है दैट इज़ VA. नाउ इसी पावर फार्मूले में हम दैट इज़ 1 2 P इज़ इक्वल टू V की वैल्यू लगाते हैं, विच इज़ V इज़ इक्वल टू IR अकॉर्डिंग टू द ओहम लॉ. Now that is I R B की जगह and I अपनी जगह, so that will become P is equal to I square R, and ये इसका जो यूनिट है that is watt. अच्छा, इस पॉइंट तक हम इन दो पावर्स को जो है ना कंसिडर करते हैं. उसके बाद फिर जब हम थोड़ा सा एडवांस जाएंगे तब हमको एक तीसरी किस्म भी है पावर की, दैट इज़ वार. सो वी विल डिस्कस दैट लेटर. नाउ रेजिस्टेंस में जब हम पावर मालूम करेंगे तो रेजिस्टेंस हमारे पास अवेलेबल है, करंट थ्रू दैट रेजिस्टेंस is not available over here. So we will have to find a current through this resistor, which is R1, R2 and R3. So in series circuit the current through resistances are same. So हम जो है ना I total मालूम कर देंगे, so that will be the current through R1, R2 and R3. So I total is equal to V total डिवाइड बाय R total. V total हमारे पास अवेलेबल है, दैट इज़ 100 वोल्ट आर टोटल हम मालूम करेंगे। तो सीरीज़ में जो है ना रेजिस्टेंसेस कनेक्टेड है R1 R2 एंड R3। सो आर टोटल इज इक्वल टू R1 plus R2 plus R3, and then we will put the values of these resistances, that is 10 plus 20 plus 30, so that is 60 ohm. That is R total. Now we got that I total over here. This is equation number 1. So I total is V total divided by R total. Now put the values of these voltage and resistance, that is 100 divided by 60. So that is around about 1.10 divided by 6 is 1.666. That is I total 1.6667 by rounding the 666 ampere. Now this is I total which is flowing through each resistor. So over here the power P1 will be over here, that is P1, P2 will be loss over here, P2, and P3 will be here. And the formula for that P1, P2 and P3 will be I square total into R1, and then I square I total into R2 and R3. सो ये फिर हमारे पास जो है ना इंडिविजुअल पावर आ जाएंगे. बट नाउ हम जो है ना टोटल पावर डिलीवर्ड बाय दिस सोर्स हम कैलकुलेट कर लेंगे विद द हेल्प ऑफ आई टोटल. फिर हम देखेंगे कि पावर जो है ना जो सोर्स से निकलती है वो आई डिवाइड होती है या सेम रहती है. सो आई पी टोटल is equal to V total I total. So that is 100 into 1.6667. So that is answer into 100. That is 166.6667. Now that is P total. ये डिलीवर्ड पावर है, कोई सोर्स डिलीवर करता है. सो देन इसका जो है ना वो बनेगा यूनिट बनेगा VA. ओके. Now this is the power, total power which is delivered by this source. Now we will have we will calculate P1, P2 and P3. Now we know that these three resistances are in series, R1, R2, R3, 10 ohm, 20 ohm, and 30 ohm. There is 100 volt. I total यहाँ पे फ्लो हो रहा है. ओके. नाउ यहाँ पे P1 होगा, P2 होगा, P3. अगर हम इंडिविजुअली ले लेते हैं, फॉर एग्जांपल R1, that is in R1 विच इज़ 10 ओहम। इसमें जो करंट फ्लो हो रहा है वो आई टोटल है, एंड वी नो दैट आई टोटल इज इक्वल टू 1.6667. Now, according to our formula, that is P power loss P1 I total square, because this is the current which is flowing through R1 R into R1. So now 1.6667 square into 10, and then here it is 1.6667 square, so that is 2.778 2.77889. That is P1, and by the way, the unit of that power will be watt. Now P2 I total, because this is the current which is flowing through R2, so that is 1.6667 square into 20. So now again 1.67 square into 20, so that is 5.5778. By the way, again over here the unit will be watt. So now P3 and by the way, if you just draw the R2, that is R2 20 ohm and I total, so that will be helping to making in concept. Over here again R3 30, and the current I total is flowing through this resistor. Now P3 is I3 over R total square R3. Now 1.6667 square into 30, and then 1.6667 square into 30, so that is 83.3366 watt. So that is P3. Now we will see that P total, which is delivered power by a source, is equal to P1 plus P2 plus P3, because these are the three power which is dropped through R1, R2 and R3. Now P total is equal to P1 is 2.777889 plus P2 is 55.5778 plus P3 is 83.3366. And now 83 plus 55.778 plus 2.777 889. So that is, wow, what's happened? I got 141.6 and we calculate that is 166, so it's a big difference. So now what will we do? What's happened? There is something in mistake by calculating these powers. So just look at again. I think we got some mistake in the calculations. So there is now bracket 0.6667 square, there is this one into 10. So there is in 27 point something, 27.777. Wow. So 1.667 again, no 1.667 square, so, and then multiply by 20 is 55. It's okay, this one is okay, and it's look okay. So now 55 plus 83.33666 plus P2 is P1 is 27.77889. So that is in 166. Wow, we got it. This was the previous calculated power, which is 166.6667 something like that, and again over here we got in 166.69 something by rounding. So that was in mistake we just made and we just corrected over here. And by the way, this is kind of practice for you people, that when there is a difference in two answers, it's a big difference before we calculate it, then how you will find out your mistake and just correct it again. So it's in 166.69333 watt. So now this was an P1, P2, P3 power, so that was this one. Now this was a first we calculate power delivered, power. This was a delivered power. Delivered power. So that was in 166.6667 something like that. And then we calculate individual power across in resistances, and then we add them over here and we got the same power. So what does it mean over here? It means that the total power is generated or delivered from the source, and then the individual powers are different because we got the different answers for P1, P2, P3, and there was in the same current flowing or through these resistances, but the value of resistance is different. So that's why P1, P2, P3 is just like in different answers. So now we conclude that the power is in the series circuit is dividing, and now we will see what is happening in the parallel circuit. Individual characteristics of series circuit is that the voltage across each resistor is dividing and the current is same. So we conclude that the power is also different. Now we will see to the in parallel circuit, that what is happening over there. Did you get my point? This one, and this one. And then this one. So in this case, we assume that this voltage is 150 volt. You may take a value for the resistances as we just take in the series circuit, so no problem. R1 is equal to 10 ohm, R2 is equal to 20 ohm, R3 is equal to 30 ohm. Now again over here we will have to find I total, and then this currents through resistances, which is I1, I2 and I3. So look at over here. For I total, we will have V total and then R total. So now we have in V total, this is the source voltage, but we didn't have in R total. Now we will calculate R total is equal to, wow, what's happened? These resistances are connected in parallel, so this formula, the previous formula, is not correct for this circuit. So now what will be the R total? So now in a parallel circuit, when we calculate the R total, that is 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3. Okay. Now we will just put the values 1 over R10 plus 1 over R20 plus 1 over R30, and then we will calculate the values. That is 1 divided by 10 is equal to 0.1 plus 1 divided by 20 is 0.05, 1 divided by 30, that is in 0.03, 333. So the total is 0.003 plus 0.05 plus 0.1, that is 0.18333. So by the way, this is 1 over R total, but mostly students making a mistake that they stop their process up to this point. So this is not the R total, this is in 1 over R total, and we have to find R total. So we will just flip this one and this one same, because when we do something over here on the left hand side, we will do the same on the right hand side. So that is 1 over 0.18333. so that will become 1 divided by answer is equal to 5 0.544545 ohm. So this is the correct and final answer, which is look good, you know. In a parallel circuit, the total resistance will be less than the lowest resistance in a parallel circuit. So the lowest resistance is 10 over here, and we got that R total is 5.4545, something like that. So it's good because this value is less than the 10 ohm resistance, which is the lowest one in the circuit. Now by finding in R total, we can calculate I total. So I total is equal to V total divided by R total. Just put the values. V total is 150 divided by 5.4545. So I total will be equal to 150 divided by answer. So that is 27.5 ampere. So 27 point. This is the I total. Now we will find individual currents I1, I2, and I3. Now this is the parallel circuit. So in a parallel circuit, the voltage across each resistor will be equal. So this resistor will get 150 volt, this resistor will get 150 volt, and this resistor will also get a voltage of 150 volt. So we can easily calculate the value of I1, I2, and I3 by considering each resistor individually. Because how we will find I1? Now we get the value of resistance R1, that is 10, and we have a voltage across this resistor which is 150 volt. Now we can find I1 over here. So look at over here, just considering an individual resistance R1, which is 10 ohm of resistance, and the voltage across this resistor is 150 volt, and we can find I1. So over here I1 will be equal to V by R, that is V1 R1. So V1 is 150 divided by 10, so that will become 150 divided by 10, that is 1 or 15 ampere. So I1 is equal to 15 ampere. How about the R2? So R2 is over here, that is 20 ohm. Voltage is 150 because voltage is same. I2 will be same formula, V2 divided by R2. So that is again 150, 20, that will be equal to 150 divided by 20, 7.5. So that is 7.5 ampere. Now I2 is equal to 7.5 ampere. And for R3, ohm. and voltage across this resistor is also 150 divided by 30, so that is 5 ampere. So I3 is equal to 5 ampere. Now just find find P power P1, P2, P3, but before we will find power total delivered by the source 150 volts. So 150 volt into the total current, that will be the power total. So that is V total to I total. So that is 150 into I total, which is how much? Which is 27.5. So 150 into 27.5, that is 4125 watt P total. So now we will find P1, that will be I1 cos square R1. So what was in I1? That was 15 ampere. So 15 square into 10. So that is 15 square into 10. That is 2250 watt. And by the way, the total power delivered by the source was not watt, that is VA. I'm sorry for that mistake, and just correct that. So now this is P1, and how about P2? I2 cos square R2. So I2, how much was I2? 7.5 square R2, that is 20. So 7.5, so 7.5 cos square into 20, that is 1125 P2 watt. And now P3, that is I3 square R3. So what was I3? That was I3 was in 5 ampere. So 5 square 30. Sorry, 5. That is I5. That is 5. So 5 square is 25 into 30. So that is 750 watt. Now we will calculate that P total is equal to P1, P2 and P3 addition. That is P1, how much is P1? That was 2250. What was in P2? That was 1125 plus how much was P3? P3 is 750. So how much is this one? 2250 plus 1125 plus 750. That is exactly 4100, 4125 watt. So that was an addition of these three. Now we will see, or we will compare that this power total by getting P1 plus P2 plus P3 is equal to the delivered power from the source. So how much was the delivered power? Did we calculate that? Yes, over here. Previously we calculate I1, I2 and I3, and then we just calculate the total power, which was 4125, and we again over here from this summation 4125 exactly the same. Wow. So just now redraw the circuit of that resistance is bit improved 100 volt. So that was R1 10 ohm, R2 20 ohm, and R3 30 ohm. And then we calculate P1, P2, P3. That was P1 was 2250 watt, and then P2 was 1125 watt, and then P3 was, what was P3 over here? 750 watt. So look at, and this over here the total power was delivered by this source, that is P total was 4125 VA. So this is delivered by this source, and then we found that P1, P2, P3 are different, So what will happen, or what we will conclude from these results, that in a parallel circuit there is a voltage across each resistor is same, that is V total, and currents through each resistor are different, that is I1, I2, I3, and we just saw that these currents are different. But over here with the power is also different, So yes, power is different, but for comparison with a series circuit, previously we calculate that these powers P1, P2, P3 was the different, So that was in previous results, So the one thing which is common in parallel circuit and in a series circuit, that is the power across each resistor, power loss across each resistor are different. So this is the common. Otherwise, when we talk about the voltage and current, so in a parallel circuit the voltage is same, current is dividing, and in a series circuit current is same through each resistor, while the total voltage V is divided into V1, V2, V3, V4, and then go on if you have and resistances. So And there was a voltage and current difference in a parallel and in series circuit. What will I do? Okay. So just we saw that the power across each resistance is in series and in parallel circuit, and that is kind of different, but the voltages and currents are the in series and in parallel circuit are alternative. For example, if we have a voltage is same across a parallel circuit each resistor, and the current will be dividing or in a parallel circuit, while in a series circuit the current will be same through each resistor, and the voltage V total will be divide in each resistor across. So that was our today lecture. If you like that, and if you like my teachings, then kindly inform me by your comments, and just subscribe my channel and get some more interesting videos. So thank you for today.